Okay, well I thought I'd take a minute today to demonstrate a new piece of hardware I've prototyped here. In keeping with the micro family name, I'm calling this the uAmp. Basically what it is, a board about the size of the board that's inside a node. It acts as a signal conditioner and booster for any node data. Say you have an SSC or you have a node where you typically run 6 or 8 null nodes. You could add a microamp after that and condition and boost the data signal so that you should get about the same performance as you do out of the microstring controller. That being, you could probably send data easily 50 or 60 feet under good conditions, possibly a little more under ideal conditions. So I've set up a quick demo here today. Basically what I have is a smart string controller, an SSC over here, power and ground going through the green wires out to a string of nodes, and my data is going through a yellow wire. So I've already kind of set this up. I'll go ahead and apply power to it, and you see sort of the problem right off the bat. I've programmed this as a white twinkling effect, but I believe you can kind of see it there on the camera. I've got quite a few other colors, some blues, some pastels, yellows, all flickering around in there, and the data is already corrupt to some extent just after a few feet coming out of the SSC. To put a little more stress on the microamp, what I thought I'd do for today is I'll add a couple of additional feet of wire in the data line here. So I'll break that apart real quick and put this in. And as you see now, we're even getting some more twinkling and corrupt colors on the nodes. They're not really showing the white flashes that they're supposed to. And if we probe the data line real quick, you can see that instead of a nice square wave, we've got quite a bit of ringing on the line. Even the ground signal is ringing. The nodes are trying to figure out where the square pulse starts and stops. So our data is looking pretty jagged coming out of there. So what I'll do is go ahead and cut this apart. I'm going to leave the coil of wire in the data line coming to the microamp, and then I'll clip the other data line to the output, and instantly the nodes take off, and now we've got our white twinkling effect that we were after. So the microamp has cleaned and conditioned that signal and then boosted it to the output side. This is based on the same technology and same design as the microstring controller, where you'd have a board with a couple of strain relief holes. You've got the option of adding a power LED that shows you've got incoming power and power to the actual board, and also a signal output LED, where with the SSC you just don't know if it has power, if it doesn't have power, if it's outputting a signal or not. With this, at least you can tell that there is power and you do have a signal coming out. Just real quick here, I'll try and probe these data lines. Get the probes on both of them at once and grab a frame of data there. So now you see that same, the blue is the input data. Kind of shows you again the ringing that we were seeing, and the yellow is the conditioned output data from the microamp. So it shows you we've really clarified that data. Even when it's pretty lousy coming in, the microamp can pick out the square wave and send a good clear signal to the nodes. So I hope you've enjoyed the little demo. Let me know what you think, and if there's enough desire for this, we may go ahead and put it into a production run.